This video will discuss Snell's law and refraction. The objective is that students will be able to recite the equation and parameters of Snell's law. Refraction is the bending of light as it travels from one medium to another. And by medium, it's like any substance that light can travel through. In this picture on the right, the light is traveling through water. And you can actually see that the straw appears to be bent in the water. It's not bent, it just appears that way because of light, because the way the light travels in that medium. A more technical way to draw this is showing that the incoming angle, or otherwise called the angle of incidence, and the angle of refraction, the angle that's bent in the new medium, in this case water, is different. So when going from air into water, the light gets bent toward the normal, which is that perpendicular line. So when light moves from air, which is something that's not dense, into water, that's something that's more dense, the ray will be bent toward the normal. When light moves from water into air, so something that is dense into something that's not very dense, then the ray will be bent away from the normal. If light comes in at a 90-degree angle, straight in along the medium, or along the normal, there's no refraction whatsoever. So the light won't be bent if it comes in at 90 degrees. Index of refraction for anything that's transparent so that light can travel through it is a way of determining an object's density. Its symbol is lowercase n, and it has no units, and it will always be a number greater than or equal to 1, so you can never have like 0.9 or 0.8 or 0.7. It always has to be greater than 1. For example, let's say that there's this substance of air on the top where this light originates, and the light rays go down into the water or glass or something more dense than air. This light will bend when it reaches it. Then when it comes back out the other side of the window or the thing of water, whatever it is, it gets bent back the way it was before because it's going back into air. That noise seemed unnecessary. So as index of refraction increases, the speed of light in that substance decreases. Basically, since n is a way of measuring density, if n is higher, then the material is more dense, meaning there's more stuff in there. More stuff being in there makes it harder for light to flow through it, so the speed decreases. And therefore it gets bent more, so the amount of bending done by the medium increases. In order to calculate all this stuff, we're actually going to use something called Snell's law, named after the guy who came up with it, whose name was Snellius, which is quite an interesting name. So we have these n values, which are the index of refraction for the first material and second material. And then sine of theta 1 and theta 2, which are the angles of incidence, like the incoming angle, and theta 2 is the angle of refraction, or how much it's bent. Here's a huge table full of a whole bunch of different indices of refraction for various substances through which light can travel. You should probably write those down, because you're going to need to know them. Not every problem will tell you exactly what the index of refraction is for that problem. It might say light enters a diamond from air. So you need to know that the index of refraction for a diamond is 2.419. Looking at diamond being 2.419, that's actually the largest index of refraction anywhere on this chart. Diamond, out of all the things on this chart, is the most dense substance. It's largely said that diamond is one of the, if not the, hardest natural known substances. We've created stuff in labs artificially that are stronger than diamonds, but diamonds are pretty tough, so they have a very large index of refraction. They bend light a lot, which helps them look very sparkly, which is why people use them in jewelry. Notice also that air, the index of refraction for air is 1.000293. So basically in problems, we'll round this down to 1 because this 293, 10, 100, 1000, 100, like 293 millionths of 1 point is insignificantly small. But technically less than carbon dioxide that has a slightly larger index of refraction. So make sure you get all these values down. You'll need them. So if you need to write them down, pause this so you can write them all down, go ahead. But in the meantime, I'm going to move on. Which of these materials will light travel the slowest? So the more dense it is, the slower light will go. And the densest thing on here is diamond. And that's the answer. That has the highest index of refraction, so it'll bend light more and slow down light the most. Which of the following is not a possible index of refraction for an unknown material? The only one of those that technically is not possible is 0.9, because values for the index of refraction must always be greater than 1. They can never be less than 1. And we'll run through a quick sample problem, but we'll spend next class talking about these two. So if light entered a bucket of water from air at an angle of 25 degrees to the normal, we know that the incoming light is 25 degrees. We'll round the index of refraction of air down to 1, and water is 1.333 if you look it up on that table. So if we plug all these into Snell's law and solve for theta r, then we'll have the answer to the problem. Refraction has a consequence that when you're looking at objects underwater, from above water, they appear to be in a different spot than they actually are. Like if this cat is looking at this fish, it appears to be where it's light, but it's actually lower than that because the light from the fish is getting bent when you look in. Same way if you're underwater looking up out into the sky, things would appear higher up than they actually are. So when you're reaching into water to grab something, you might have noticed that the object isn't exactly where you thought it was. And that's because the light that you see from it is getting bent when it enters air. Thanks for watching. Remember to bring your notes with you to class next time and answer all those Edmodo questions. See you next class.